Hello everyone and welcome to today's live stream. Today we're going to be talking about the transaction lifecycle on Shardeum. This is something that I think is important for developers and also just for end users who are going to be transacting on Shardeum, who is going to be sharing tokens and transferring tokens to get a good idea of how it all works and how the Shardeum network is a little different from what you might be used to from other blockchains or from other layer 2 solutions. So I want to start from, let me zoom in a bit. Okay, so usually the experience that I want to try to replicate here is the experience of someone who's sending or transferring tokens from one wallet to another wallet, right? So let's say that I have a wallet, I have some SHM tokens in it, and I want to send some of those tokens to Sonia, right? The first thing you want to do is to express an intent to send money, right? That could be just opening MetaMask, right? And putting some values you want to send and the wallet address that you want to send it to. So this is me, and this is my balance. I've got a wallet, and I want to send money to Sonia, right? So I open MetaMask, I put in my the wallet address, Sonia's wallet address, and the amount I want to send, and then I hit next. So what happens from this point forward is that MetaMask is going to ping the Shardeum JSON RPC server and say, hey, get me an estimate of this transaction. And then the JSON RPC server is going to use the local data RPC server and take everything that I've provided for that transaction. It's going to use it to kind of like simulate a local transaction to predict the computational resources that the transaction is going to need. It's also going to fetch like a nonce, which will be a unique identifier for that transaction that it's going to use to identify it. And it's going to get all that data back, and it's going to send it back to MetaMask like, hey, for this transaction that you want to perform, this is the gas fee that you will likely pay. This is your nonce. It's probably not going to display the nonce, but it's also part of the payload that gets back to MetaMask. So this is the point where we're sending this. I'm sorry, I've not been using the diagram, kind of just been showing it. But yeah, so this is the point where the data comes back to MetaMask, and MetaMask displays that data back to the user, who in this case is probably myself or anyone else who's making the transaction. And you see the gas fee, you see some details about the transaction that you want to make, and it's then up to you to say, hey, I want to proceed with the transaction. Or you could say, okay, the gas fee is a little too high, maybe because the network is busy, or for whatever reason, I will do it another time. But if you do want to proceed with the transaction, you could say like, hey, I'm happy with the fees, and then you go ahead and sign that transaction with your private key. So you do that on MetaMask. So once you've signed that transaction, what happens is MetaMask then submits the transaction that you've just signed back to JSON RPC server like, hey, the transaction has been signed, we're happy to proceed, right? And then again, the JSON RPC server is the interface to submit transactions to the network. It handles a ton of different network queries. So this is how other dApps and other applications interact with the Shardeum blockchain, is through the JSON RPC server. So MetaMask will submit that transaction to the RPC server, which will then inject that signed transaction into the Shardeum validator network, right? So the transaction gets in here. Now, this is where the actual processing of the transaction starts to take place. When the transaction gets into the validator network, it starts off in a waiting state where it spends about 6 seconds for the transaction to mature, for the timestamps to be looked at, for the transaction to get into the existing queue. All of that would happen in the first couple of seconds that the transaction gets into the validator. And what would happen is when it's time for the transaction to be processed, probably in a couple of milliseconds, it gets into one of the active validators, right? So locally, when you're running the Shardeum network, you will likely be running with like a network of 10 nodes or maybe 20 nodes, depending, right? But first, it gets into the transaction gets into. Hang on, let me just grab this from here. It gets gossiped down to into the first validator, and then the validator uses what we call the gossip protocol. This should be here. It uses what we call the gossip protocol to spread that transaction information to all the other active nodes in the network. So at this point, all of the individual nodes, they all have data about the transaction being processed. And that way they can start, processing the transaction and forming consensus and executing the transaction. Once that is done, a couple of things happen behind the scenes to go from receiving the transaction to executing it and forming consensus on it and generating a receipt. All of that happens behind the scenes. The validators, they talk to each other, and when they are done and they are all in agreement that the transaction has succeeded, we get into what we call the commit phase of the transaction, which is where data flows backward to kind of update all the nodes that are participating in this transaction that, hey, this is the current state of the accounts that has been affected by this network. So wallet A is going to get debited by maybe $10, wallet B is going to get credited by maybe $10, and that way, like, all the nodes that are participating in that network has the updated state of both accounts. And then the receipt of the transaction is generated, because at this point, transaction is successful. The person who's sending money has been debited. The person who is receiving money has received the balance in their account. So a receipt is then generated and signed by the validators and sent to the archive server. But this is one scenario, right? What I've basically explained here, what I've shown now, is what happens when both accounts that is inside one transaction are handled by validators in one shard, right? So that shard doesn't need to communicate with anyone else. All the transaction, all the execution, all the consensus, everything happens inside of this one shard, because account A and account B are all handled by the validators in that one shard. The second scenario could be that you're sending money from wallet A to wallet B. Let's say that wallet A is handled by this shard, and we have wallet B handled by a separate shard. What happens is then the nodes in this shard is going to need to talk to the nodes in a different shard. Let me grab that actually. Okay. So now we have two shards. I'm going to call this shard 1 and 2 so that it's easier to see for people who are watching. All right, so let's say that I'm sending money from wallet A to wallet B. Wallet B is in shard 2. That's the validators that are responsible for that account are in shard 2. But the validators that are responsible for the first account, which is the wallet A, is in the first shard. So in situations like this, the validators in shard 1 need to ask for that information from the second shard. Like, hey, we want to process a transaction for this account. You hold all the data about the account. Can you give it to us? And then shard 2 validators are going to send all of that information back to shard 1. And this communication happens through what we call the corresponding tail, which is the mechanism of shards and validators in different shards talking to each other, sending messages across. And something that I think people get wrong sometimes when we're thinking about this life cycle is that both shards will form an execution group, form a consensus group, and do all the transaction processing together, which is not the case, right? They do form the transaction and the execution group, but they do not process the transaction together. So what the second shard does in this case is basically just give information to the first shard. Like all the validators in the shard 1 they will receive all that information, and only one shard will be responsible for the actual processing of the transaction. However, when the transaction is done, all the nodes in both shards get updated with the current state of the accounts that are involved. And when everything goes well, then we come back to the transaction receipt being generated and sent down to the archive server, right? The archive server will authenticate just to validate that the receipt is accurate, and then store it in an internal database that we call the archive DB. Then the archive server is not optimized for queries. You cannot like send queries to it as you would normally do to a regular database. However, it is very optimized to retain information for a long period of time. So what happens is as the archive server saves that transaction receipt into the database, it would send that data again to the distributor. The distributor works like it uses WebSockets to basically get real-time information from the archive server and update the collectors that are depending on it. Multiple collectors could be connected to one distributor because the distributor basically gets information and sends it to all the places that it needs to go, which is something that the archive server on its own is not very optimized for. So it gives the data to the distributor that sends it to all the collectors that need it, and the collectors would then send it back to the JSON RPC server. The archive server would also send that data to the Explorer collector because again, if you've done transactions in MetaMask before, you would often see that when you complete the transaction, you get a message on MetaMask saying that the transaction is successful, and this is a link to the Explorer where you can go see that it is indeed successful. So the archive server is also what feeds data to the Explorer collector to update the Explorer as well. Now, when the collector receives the message, it sends that at this point, MetaMask is constantly polling for results of the transaction that it initiated, right? After it submitted the signed transaction to JSON RPC server, it doesn't stop the network here. It basically keeps looking for a result, like what's the state of the transaction? Is it successful? Has it failed? Basically polling at intervals to get some kind of response back. So eventually when the transaction receipt and transaction data gets fed back to the JSON RPC server, then MetaMask gets the notice like, hey, the transaction has been successful. And at this point, it comes back to tell the user like, hey, transaction is successful. Here is a link to look at it in the Explorer. And the user, in this case myself, can now go ahead and click on the Explorer and see the transaction details. Now, this is a brief overview of how the token transfer transaction happens on the Shardeum network. You see all the different services that have to play a part. I didn't actually even cover the monitor server that keeps an eye on all of these things and make sure that it's looking at the transactions that are happening and have a UI that you can also look at to look at that. I think I might have that, but yeah, I'll come back to it. So the transactions in a little bit of a summary. If there's a question as I'm talking, please put it in the chat and I'll be happy to look at it. But yeah, just a quick recap. The user initiates a transaction. The transaction goes through MetaMask, where the user will provide the transaction details, who you're transferring money to, and how much you want to send. The JSON RPC server is going to get a gas estimate and a nonce and send that back to MetaMask. MetaMask will let the user know like, hey, this is the gas fee that you will likely pay. The user will sign the transaction with their private key and send it back to MetaMask, which would then submit the transaction back to the Shardeum JSON RPC server, which would then inject that signed transaction into the validator network for processing. The validators in the network will process the transaction, reach consensus, update their states, and commit the current data across all the validators in the network so that everyone is updated. And then a transaction receipt is generated and signed by the validators that participated in the transaction, and the receipt gets sent down to the archive server. The archive server receives the transaction receipt, it saves it in the database, and it passes it on to the distributor and to the Explorer collector. The distributor would pass that data to every other collector that needs it, and then this collector will receive the data, send it back to JSON RPC server, which will then update MetaMask, and MetaMask will let the user know that the transaction has succeeded. And this is the point where we can go ahead and give someone else the receipts, generate a link from the Explorer to the transaction and give it to them, perform whatever else you want to perform. So a typical use case, I think I have, I'm not sure, but I think I have a network running locally. I planned to like show you how that would work in practice, but I'm not sure that I've set it up. I'll check. Yes, so I have, the network is not running at the moment. I think I had stopped it at some point. But what happens is you can come on to MetaMask. Let's assume that I have 200 or however much SHM tokens in this account. You can select that account. You can see that I'm on the Shardeum network. Click to send. Select an account you want to send it to. Put some amount. And of course, there's zero SHM on this account, so I don't have any money for gas fees. But what would happen is you're going to get estimated gas fees. You're going to come to this point, confirm the transaction, and what will happen is the transaction will basically get into the validator network. After you've signed it, it gets processed, and at the end, you will see that you have sent money to that account, that amount of SHM token that you sent. And that would be how the life cycle of a transaction typically looks like on Shardeum. I am going to stop here. Let me see how much time I've got. Yeah, I'm a bit over. But yeah, if there are any questions that anyone has, I'm going to try to come back to Discord now to answer those questions. Otherwise, before we go, I wanted to let you know that we have all of the different live streams that we've been doing for the past couple of months available on the YouTube playlist. We have a built-in public YouTube playlist, so you can catch up on all of the things that we have going on there. Next week, we are going to have another session where Sonia is going to walk us through some things. I haven't looked at the sheet to know what topic we have coming on next week, but it's going to be an interesting one as well. After that, I'm going to come back and I'm going to do some updates to the network monitoring site that I've been working on this stream for some time now. There's been a couple of changes that I'm going to be making on the site, and I'm going to be making it live on the stream. So do join us. I'm going to schedule all those events after this call so that you can go on RSVP and get notified when that event starts. All right, I'm going to stop sharing now, and I'm going to see if there are any questions in the chat. Oh, thanks for the demo. Joao, thank you very much for joining us. Okay, I have another good news, and that is that for these events, we are going to start issuing POAPs. We're currently in the process of setting that up, but keep attending. I just want you to know that we do appreciate you for joining these calls and helping us build Shardeum as well in the OSS Devs channel. If you're not there yet, please go ahead and join us. We have a channel that I've put in the chat where we help build Shardeum together with the rest of our community. So if you're not there yet, join us and keep on with the conversations. And as you continue to interact, help people answer questions, file issues, send pull requests, all of these activities we appreciate, and we will start issuing the necessary rewards for them soon. Any last words from you, Sonia, before we go?
I think you have covered it pretty well. So just keep an eye, and thanks everyone for joining.
Awesome. Thank you all for joining us today, and we hope to see you back next week. Bye, everyone.